Okay, hi guys. So this one is about polarisation and Malus's law. So I've tried to draw a few things out already so it saves a little bit of time. And when we're talking about polarisation, we're talking about taking a wave from being unpolarised to becoming polarised. Okay, and in this case, we're talking specifically about transverse waves. Okay, so an unpolarised wave, okay, oscillates in different directions. Okay, so we've got it oscillating in many different planes. Okay, so unpolarised, okay, it oscillates in different planes. So when we talk about them being polarised, okay, that's taking away from them oscillating in many different planes to oscillating in one plane only, so one direction only. So we'd say this one has been vertically polarised. And this one has been horizontally polarised. Now, it's sometimes a little bit hard to visualise what's going on because we want to represent waves just as this kind of a wiggly line. So we sometimes just think that they're vertical, but they're not. Remember, a transverse wave is actually an oscillation of an electromagnetic field, okay? So the field is oscillating in all these different directions, okay? But they're always at 90 degrees, okay? So they are perpendicular to the direction that the wave is travelling in, okay? So I could have it oscillating in this direction as well. Sorry, it's a terrible wave. That's why I don't tend to draw when I'm doing this live. Okay, so we can see the direction of the wave and the oscillation, they are perpendicular. Okay, so they have to be perpendicular for them to be polarised. If they're in the same direction, they cannot be polarised because what they do is they pass through some sort of filter, okay, whereas if they were a longitudinal wave, they wouldn't be polarised going through because their vibration was in the same plane, so it would just continue going. So only transverse waves can go through polarisation is what that was a very terrible attempt at trying to explain there. Okay, so when we're dealing with this in terms of polarisation, we're often looking at it passing through filters. Okay, we can also have it being polarised through reflection as well, but the questions that we tend to use with the diploma tend to revolve around filters. Okay, so the first thing we always called this one, we called this first filter the polarizer. And the second filter is known as the analyzer. Okay, so if we think about our first one, we've got our unpolarized light. Okay, so let's say it's adding in many different directions. So I'm just going to represent this with my arrows. Okay, going through. That's again really terrible. I should not be drawing this. Okay, going through, and it's going through a polarizing filter with the filters are in this direction, so we end up with it coming through being vertically polarized. Now, it's really important to note here that the intensity beforehand, so I'm going to call this the intensity originals, I'm going to call it intensity A. Okay, the intensity after the first polarizer is always 50%. Okay, so this is always 50% of the unpolarized light. Being really careful, it's the intensity I'm talking about here. Okay, so it's always like cutting off, so even all these ones that are at angles, okay, it's only letting through half of the wave essentially. Okay, so 50% of it comes through. We then go through a second polarizing filter usually in these questions, and this one's called an analyzer, and this can be at different angles, okay, so different angles to the first polarizer. All right, now in this case, we've got this in the horizontal plane. So if I've got vertical light going to a horizontal plane, none of it is let through. So the intensity after this is going to be equal to 0. Okay, so when that is at 90 degrees. Okay, so if we've got them there, and that's something really important to remember. The next kind of a situation I'm going to just look at, again, is with the polar and the analyzer, but I'm going to have the analyzer just being at a specific angle here, and this is what we're going to use to represent Malus's law. Now, with Malus's law, it's given by the equation I is equal to I naught cos squared theta. So theta is always the angle between the polarizer and the analyzer. Now, I've drawn mine in the vertical plane, but the question could give you it in a horizontal plane. The question could already give you it at an angle. Okay, so just be really careful. Don't always assume it's vertical. Make sure you have a little read of the question. I'll do some example questions for this as well. And then we have it being at its angle with the analyzer there. Now this I naught here corresponds to the intensity between the polarizer and the analyzer. So this is I naught here. Okay, so this one we have to be really careful. This is the I naught, is the intensity there. And then this I, okay, is the intensity of the wave coming through afterwards. So the intensity here, all right, is equal to I naught cos squared theta. Okay, just being really careful. Remember, they might in the question not give you I naught, they might give you I original. Okay, so if that's the case, the equation for I, all right, could be IA divided by 2 cos squared theta. All right, so being really careful at what they are asking you. And remember, it's a cos squared, so if we're typing that in our calculator, we just do cos of the angle and multiply it, or sorry, not multiply it, but square that whole thing. Make sure as well, when you're doing this, your calculator is in degrees, not in radians, all right, because we're using our angles in degrees for this question. That also makes sense for when we've got it at 90 degrees, because cos squared of 90 gives me 0. The other thing that they might give you then is if we rotated this through, if we started off at angle 0, I'm going to get the full intensity out. If I rotate to 90, I'm going to get minimum intensity. If I go down to rotating it again, 180, I'm going to get maximum intensity. So sometimes they get you to sketch a graph. So if I was dealing with the angle, so let's say I've got a little intensity graph here. So I'm going to put intensity on my y-axis, and I'm going to put my theta, okay, between the polarizer and the analyzer. Here, if we go to angle 0, let's then say we'll go to, let's say 90, and then we could go to like 180 there. All right, if I was looking at this, so let's say this was let's say this was IA actually. Okay, this is going to take me then to this one being I naught. I would have to be really careful. I would talk about I naught being half of the original intensity, so I'd start here, and I would draw down, going to a minima at 0, minima 0 at 90, and then bring it back up to a maxima at 180, giving that cos squared graph. So something to watch out for. I have seen this in a question before where they actually put the intensity on the side. If it was intensity 0, you'd start from the top up there. So just being really careful with that. Giving you that cos squared theta graph. You could go along further to doing like 270, 360 as well, giving you continuing that shape. And I think that's a very quick little overview of polarization. Let me know again if you need any more detail or any specific bits, and I can also make a video for that.